Unit 5.4, the derivative test. The first derivative test is when we use the first derivative to test whether or not a function has a maximum or a minimum. Start with something we know. A quadratic function's graph is a parabola. We know f of x equals x squared minus 4x minus 2 opens up, so f will have a minimum. Examine the graph of this parabola and describe the behavior of f prime of x around the minimum. So we know that the minimum is right here, right? Now we notice that leading up to the minimum, the slope is negative, and going away from the minimum, the slope is positive. Justification statements. Assume c and d are critical numbers of a function f. There is a minimum value as x equals c because f prime changes signs from negative to positive. There's a maximum value at x equals d because f prime changes signs from positive to negative. 1. Use the first derivative test to find the x values of any relative extrema of f of x equals x squared minus 4 to the power of 2 over 3. First, we're going to have to find the derivative of this using chain rule. And we can find that f prime, I've already done it out, but just apply chain rule, and the derivative is 4x over 3 cube root of x squared minus 4. Now, first we have to find what will make this undefined. X equals 2 will make this 0. That's undefined. And then what value will make, or also negative 2 will make this undefined, and then what value will make this equal to 0, so we just plug a 0 into the numerator. So these are our critical points. Now we can draw our table f prime of x, negative 2, 0, 2. We can put d and e's under the 2's, so 0 under 0, d and e. Okay. Now we know we put the domain 0 to 2 to infinity. Now, by plugging in numbers within the domain into the equation, we can find out whether they're positive or negative. Just to make it fast, I've already done it. So, negative and positive. Now, we can draw to visualize it. So this is negative, so this is going down. It's positive, so it's going up. This is 0, so it's like a plateau. This is going down. It's D and E, so there's nothing here, and this is going up. Now, our answer, our justification statement, there's a min. So everywhere there's a min is when it goes negative to positive. So negative to positive is a min right here, and a min right here. Min at x equals positive and negative 2 because f prime changes signs from negative to positive. So max is the exact same but opposite. It is when it goes, so you can notice that there's a max right here because it goes up and down. There's a max at x equals 0 because f prime changes signs from positive to negative. If h of c does not exist, then x equals c cannot be a critical point. So for this, we find the derivative using quotient rule. and I've already done it, so I'll just write down h prime of x equals x 8 minus x over 4 minus x squared. Now we look at what number would make it does not exist. Right here, you can already see that positive 4. But if you plug in a positive 4 right here, this will make the original equation or function does not exist. So that cannot be our critical point. And then what will make it equal to 0? Like you see that 8 will make it equal to 0 and 0 will make it equal to 0. So our critical points will be 0 and 8. But we also want to include the 4 on our table. So it's right here so I don't forget. Our table, x, h prime of x, 0, 4, 8. We know that these are zeros, and this is just a D and E. Now we put in domains. Negative infinity is 0, 0 to 4, 4 to 8, 8 to infinity. I've already done them, but you just plug in a number within the domain into this equation, and we'll find that this is negative, this is positive, and this is negative. Draw it out. Oh wait, it's positive. So looking for mins. Mins is when it goes negative to positive. So there's a min right here. There's no other mins. So min at x equals 0 because f prime changes signs from negative to positive. Our max is the other way around, so there's a max right here. It's our only max. Max at x equals 8 because f prime changes signs from positive to negative. Also, what is the maximum value is not the same thing as where is the maximum.